Okay, we are now starting Unit 11. This is Unit 11, Lesson 1, and we are solving quadratic equations by finding square roots. And your two objectives are listed here, so let's go ahead and get started. Okay, one of the things you want to know for this entire unit is the difference between perfect squares and non-perfect squares. Okay, a perfect square number has a rational square root. And what a rational number is, it's either like a whole number, positive or negative, or it's a decimal number that stops or repeats itself. Okay, so a rational number is pretty much anything except for a decimal like pi that goes on forever and never repeats. Okay, so some examples of perfect squares are listed here, and these are ones that you'll definitely want to know for the entire unit. Okay, for example, the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. Okay, now notice the square roots are all whole numbers. Okay, they're rational numbers. So 0 is a perfect square, 1 is a perfect square, 4 is a perfect square, 9 is a perfect square, and 16 is a perfect square. And we can go on. Square root of 25 is 5, square root of 36 is 6, square root of 49 is 7, square root of 64 is 8, square root of 81 is 9, square root of 100 is 10, the square root of 121 is 11, square root of 144 is 12, square root of 169 is 13, because 13 times 13 is 169, square root of 196 is 14, and the square root of 225 is 15. Okay? Now, non-perfect squares, okay, have irrational square roots. So, for example, 21 is an example of a non-perfect square. Okay? Reason for that is because if I take 21 and punch it into the calculator and push the square root sign, I'm going to get 4.5825, yada yada yada, and it just keeps going on and on forever and never repeats itself. Okay, likewise, the square root of 75 is 8.66025, and it goes on forever and ever, never repeats. So 21 is a non-perfect square, and 75 is a non-perfect square. Okay, these ones up here are ones that you'll probably want to memorize, okay, because they'll help you throughout the whole unit. Okay, let's move on to the next slide. Okay, now we're going to start having some different meanings of square roots, okay? And the way your book's going to represent it is by these symbols here. So this symbol means that your book just wants to know the positive square root of the number. So for example, if it asks you for the square root of 4 looking like this, and the answer is 2. Okay? If it asks you for the square root of 0.25, okay, that's 0.5, because 0.5 times 0.5 equals 0.25. But your answers are positive numbers when there's no symbol out in front here. Okay? If they want the negative version of the square root, then they might do this. Okay? Put a negative sign and the square root of 9. And that answer is negative 3. Okay? Because negative 3 times negative 3 still gives me positive 9. Okay? Or if we said negative and the square root of 0.49. Okay, it'd be negative 0.7. Because negative 0.7 times negative 0.7 would still give me a positive 0.49. If they want you to list both square roots, then they'll put the plus and minus sign in front. Okay? So a plus or minus square root of 64. Okay, and I'm actually going to take this and write it down here where I have room, so we'll erase this. Okay, I'm going to write it underneath here where I have room, but you can write it in this box up here. Okay, just because I'm out of a little room here. So plus or minus the square root of 64, and you would put positive or negative 8. Because positive 8 times positive 8 would give me 64, and negative 8 times negative 8 would give me 64. Okay, and if we ask for the positive and negative square root of 0.36, then we'd put positive and negative 0.6. Okay? Now, no real square root, it doesn't have a symbol, but we have to understand that sometimes there's not going to be a real number square root. So, for example, the square root of, let's try negative 16. Okay? Well, square root of negative 16. There is no number I can take times itself to give me negative 16, because 4 times 4 is positive 16, and negative 4 times negative 4 is still positive 16. So the answer is no solution to this. Okay? I'm going to go ahead and get rid of these down here for a second, because one possible answer that you can write during this unit is no solution. Okay? And I'm going to teach you something that your book does not teach you, okay? Your book will always assume there's no solution to this answer. But in Algebra 2, you're going to learn about something called imaginary numbers, okay? And the imaginary numbers are just numbers that mathematicians made up so that you could solve a problem like the square root of negative 16. So, for example, okay, the square root of negative 1. Okay, the square root of negative 1 is the definition of an imaginary number, and the answer to that is I, okay? I is what mathematicians came up with to represent the square root of negative 1. So anytime I want to take a square root of a negative number, so for example, if I want to take the square root of negative 121, okay, I'm going to figure out the square root of 121, which is 11, and then put I after it, okay, because the square root of 121 is 11, and the square root of negative 1 is I. So the square root of negative 121 is 11i. And we could say the square root of negative 225. Can you guess what that would be? Well, the square root of 225 is 15. And since the negative is underneath the radical, we just put an I. Okay, so I will accept for this unit either one of these answers, where if there's a square root of a negative number, you just want to put no solution, that's okay. But if you want to put the number with an I after it, that's fantastic, okay? Again, that's an Algebra 2 topic. So we'll be talking about that in a couple years in math. Alright, let's go on to the next example. Okay, there's going to be some examples in your book where it asks you to evaluate this right here. Okay, this is called the discriminant. Okay, we're going to talk about the quadratic formula in a few lessons. Okay, and this is part of the quadratic formula that you'll need to know how to solve for. So if it says to evaluate it, they just want you to plug in the numbers you're given and solve for it. Okay, so for example, for this first one right here, we're going to evaluate when a equals 1, b equals negative 2, and c equals negative 3. So the first part is b squared. That means I'm taking this whole thing squared. So again, we talked about this last unit. I'm going to put this in parentheses. So that's negative 2 squared minus 4 times my a is 1 times my c is negative 3. Okay? And again, now we can change the subtraction to addition if we want to. Okay, so we're going to have negative 2 squared plus negative 4 times 1 times negative 3. Well, negative 2 squared is 4, because negative 2 times negative 2 is 4, plus negative 4 times 1 is negative 4, and negative 4 times negative 3 is 12. So now I've got the square root of 4 plus 12, and that's the square root of 16, which is equal to 4. Okay, so 4. Now, we're just putting positive 4 because there's no plus or minus out in front here. Alright, let's do the next example here. We're going to do the same thing. Okay, we're going to plug in, this time 0 for b, minus 4 times a is 1 times c is 4. So we can change this now to addition. And 0 squared is just 0, so we can just kind of get rid of it. Okay, and then negative 4 times 1 is negative 4, and times 4 is negative 16. Oh, we've seen something like this before. We can write this two ways. We can put no solution, or we can take the square root of 16, which is 4, and put I after it, 4i. Okay, and that's how we're going to evaluate this thing again. It's called a discriminant. Alright, let's go on and keep moving on. Okay, and now we're going to talk about solving for quadratic equations, okay? And the standard form of quadratic equations is this right here. Ax squared plus bx plus c equals 0. Okay, where a is not equal to 0. Because if a equals 0, then anything times 0 is 0, which would just kind of get rid of this ax squared part. So we'd just be left with this, and that would be a linear equation. Okay, because quadratic equations have to have something squared. So for example, it can look like this. We could have 7x squared plus 5x plus 8 equals 0. Okay? we could have 7x squared plus 0x plus 8 equals 0, which would be the same as just 7x squared, 7x squared plus 8 equals 0. Okay, so they can take this form right here where there's no x value. But again, we have to have the squared part for quadratics. Okay, otherwise they would be linear equations. Okay, and again, we can have something that looks like this. 7x squared plus 0x plus 0 equals 0. And that'd just be the same as 7x squared equals 0. Okay, because we got rid of the x and the constant part. Alright, in this form, a is called the leading coefficient. Okay, so if I talk about the leading coefficient of a quadratic equation, then that's this number a right here. So the number that's attached to the x squared. Alright, and let's go ahead and move on to solving quadratic equations. Okay, when solving for quadratic equations, first thing we need to do is get the x squared by itself. Okay, in this case, x squared is already by itself, so now we're going to take the square root of that. So x is going to equal the square root of 36. Okay, now whenever I solve a quadratic equation, I want the positive and negative version. Okay, so in this case, x is plus and minus 6. Okay, so I'm going to go ahead and put plus and minus in front of this too. Okay, so again, when you got the squared by itself, you're just going to take the square root of whatever this is. Well, here, in the second one, we've got to get x squared by itself first, so I'm going to divide by negative 2. And these cancel, and I get x squared equals 14 divided by negative 2 is negative 7. Okay? Well, then I would take the square root of that. So we're going to say that x equals the positive and negative square root of negative 7. Okay, so we can say that x equals no solution. Or we could say that x equals positive and negative the square root of positive 7 times I. Because I don't know what the square root of 7 is. Okay, so I can just write as the square root of 7, and then again put an I afterward because there's negative underneath the radical sign. So either one of those two answers will work, whichever one you're more comfortable with. Okay, next example, again, we have to get the x squared term by itself first, so I'm going to add 48 to both sides. And I get 3x squared equals 48. Then I would divide by 3 and get x squared equals 48 divided by 3 is 16. So x is going to equal the positive and negative square root of 16, which is plus or minus 4. Okay, so again, all we're doing at the end after we get the x squared by itself is taking the square root. So we're solving in the same way as we did if it was just x, okay, by getting this by itself, but then we have to take the square root at the end. Same thing here, we're going to subtract 48 to start with. So I get 3x squared equals negative 48. If I divide by 3, I get x squared equals negative 16. So then I'm going to take the square root. So I say x is equal to the positive and negative square root of negative 16. And again, since it's a negative now, we can say that x equals no solution. Or I could say x equals plus or minus. Well, the square root of 16 is 4, and since there's a negative underneath the radical, there's got to be an I. Again, either one of those, whichever one you're more comfortable with, is the one I want you to use. Alright, and that's it for your lesson. Good luck on the homework.